Y'all ready to go? Let's do it. Five eight. Let's go. You should have a calculator in front of you in addition to your notes. You are going to want a graphing calculator. If you relied on your phone, if you had an app on there, the Android one, the Wabbit, will work. The one on the iPhone that we found does not do what we're doing today. So he's taking the test, which is ridiculous that she even has to take that. Huh. Just wanted to see what it's all about, I guess. Yimmy's still out. No, I did not get to the books yet again. I stared at my desk, and basically it's a dissociative state. It happens. Today, you know how to do pretty much everything from today. We're just going to do a lot more of it. I also have very little patience, particularly for interruption, because I've been up since 4, and that sucked. So, sleep deprived, cranky, just to let you know ahead of time. So, if I kind of start twitching and then fly over the table and just take out Dawson, like, that's what's up. So,
well, I had my notes and I had a pencil in my pocket, so and I just didn't even take it.
It's like, go for it, dude. Okay.
Put this on.
Do you all remember how to do linear regression? Yeah. How to get the line of best fit? Talk to me. How?
I'll show you.
You got a bunch of data on the table. What do? Make the line that fits this the best. How do you do it?
Stat calc.
Okay. How do I enter my data to begin with?
Y equals. Nope, sorry.
Stat edit. Okay. We start with stat edit. We type in a bunch of data. Once I got my data, then we
stat calculate.
Stat over to calculate. Remember, calculate happens in 2 places. There's a second, right above trace, calculate. That calculates stuff that is on your graph right now. If I'm trying to create a function for my table, then it's stat over to calculate. Now, so far, we have done linear regression. Make me the line of best fit. Then last chapter, we reviewed that and said, oh, hey, look, you can also do quadratic regression. Take a look at all the different kinds of regression that you can do. Okay. You already did this and this. Today we do those. This is linear regression again, but for a different type of format. This happens in chapter 7, wait, we already did that. That was monomials. So this one's already done. These ones are coming up next. Okay, logistic. We'll see it in pre-calc. It's just another button, but it's got its uses. They're all just different buttons. Same process, different button. Okay, if you're running a Casio, same thing, as finding your linear or quadratic model when it's, what is it, like, it's like gsolve and then function and then it's one of the options. Okay. We need to get good with these because we're going to put multiple of them on the same screen and decide which one's the best. See, mostly, what, sophomores in here, so sophomores and juniors. Okay. You ever had to get something fancy? Fancy clothes?
Yeah.
Wedding, funeral, prom, whatever. Okay. You got to get the fancy clothes. There's different things to choose from, and one of them might fit a little bit better than the other. Women are notoriously terrible about this, but they will choose the one that looks the best, even though it doesn't fit the best. But look at it. Okay? Especially shoes. The hell is wrong with you with your shoes? Those are torture devices. Wrong with you? I wore like Skechers to my own wedding. I'm gonna be comfortable. No. If I have to wear the suit and all that and the thing strangling my neck all day, I'm gonna wear comfortable shoes. Okay? I also have an incredibly understanding wife, and I don't know how the hell I found her. So, we're gonna get a set of data, and we got to decide not just what fits the best, but also what makes the most sense. Just because it fits the best doesn't mean that it's the most appropriate for what you want it to do. Okay? So we're going to start with, we'll have a table. Do you remember how to get that scatter plot? It's been a while. There you go, right above y equals. Second stat plot. And you'll turn your plots on. And once you got your plots on, you can either manually change your window, right? Go to window, and I would just make my x's and y's match my data in my table. Or I can get real lazy and say zoom to my option number 9, stats. Now right now, I don't remember when the last time was I did anything on here, but if I try to say zoom stat, oh wait, it does have stuff on there from before. Okay, I was doing this with pre-calc when we did our logistic models not too long ago. So if I have my stat plot and say zoom stats, okay, great. If I say zoom to my stats and I don't have a stat plot on, it won't do anything. So we've done all this before, just trying to refresh your memory. The catch is when I look at that, I have to decide which one makes sense. Well, that didn't do much. That is clearly not a line. This is going to have a correlation coefficient that's higher. It's going to literally be a mathematically better fit. But it still doesn't hit it perfectly, right? And then I come over here and hits it absolutely perfectly. Okay, so we need to decide what's going to be the best fit. What is a polynomial function that passes through these? Okay, there's something called n plus 1 point principle. It's right there at the top. It says if I got 4 points, there's a cubic that hits it perfectly. If I've got 3 points, there's a quadratic that hits it perfectly. If I've got 5 points, what is there? It's always one less. 5 points, there's a quartic that hits it perfectly. It might not be the one we choose, though. It's saying, like, look, Sullivan, it's been 2.5 years. You're like 70 pounds over what you used to be. You know, that kid really wrecked you. You're going to have to go to the big and tall store if you want someone to actually size you up right. And I go over to the big and tall store. I'm like, all right, size me up. And they find the one that's a perfect fit. And I'm like, but it itches. I don't want that one. Maybe I find what's going to be perfect here. What type? cubic, right? There's 4 points. So there's a cubic that fits it perfectly, but maybe the perfect fit isn't the most reasonable in context of a word problem. Okay? Because maybe the model shoots off into the wild blue yonder and it says in another 10 years there's 38 trillion people on the planet. That's not happening, right? Unless every single person on the planet literally makes it their mission to pop out as many kids as possible. I still don't know if we can get that. Okay? No, you don't comment there because I'm terrified at you reproducing. So, what is a polynomial that passes through these? I see. Okay, when we have our FUBAR day and y'all are playing like old granny games, okay, y'all know how to play Life? We have Redneck Life up there. It is literally the game of life that has been redone in Redneck. So instead of like stopping and then getting your college degree and what is your career going to be, you stop and you drop out of school. And then you get your job at the convenience store or as a taxidermist or whatever. And then the next one, you get married. Yeah, cool, great. And then the next one, you get divorced. And then the next one, you get remarried and you have to roll dice to see how many redheaded stepchildren named Daryl you get. You win the game by whoever has the most teeth left at the end of the game. Yes. But you start with your teeth and then you like draw the card and it says, you know, got in an argument with your sister cousin, lose 2 teeth. Like that's the game. So have fun with it, okay? But anyway, a polynomial that has these particular points, let's go ahead and plug them in. Go to, first of all, I have no idea who has calculator that pre-calc was actually using before, so how do I reset this and just start from scratch? I told you you'd know it. 2 plus 7, enter 2. Okay. 2 plus 7, enter 2. Now, not just memorizing that, but remember second and then right above plus is the memory option, and it asks you what you want to get rid of out of the memory. Okay, so I'm going to stat. I'm going to edit, and I'm going to type in those points. Okay, how do I type in coordinates instead of a table? X's and Y's, right? 0, 1, 2, and negative 1. So 0, 1, 2, negative 1. And negative 3, negative 1. Get over there. Negative 3, negative 1, 5, negative 7. Okay, I've got stuff. Stuff is 4 points. If I have 4 points, then I have a cubic that hits it perfectly. So I will go stat. You know what? Before even that, turn your stat plot on. I want you to actually look at it. Second y equals is your stat plot. Turn it on. Now that I've turned on the plot, I should be able to zoom to my statistics. And you're like, what's the big deal? Almost looks like a line. Okay. I want to show you, just rapid fire. Do y'all remember where the correlation coefficient was? Correlation coefficient. How good of a fit it is. If you're on a TI-84 plus or better mode, and you literally just turn stat diagnostics on. Okay? If you don't have that type of calculator, old school, we would go to second, right above 0 is the catalog. The catalog is literally every single thing that your calculator can do, every operation. It's absolute value, you putz. I don't want to scroll all the way down to D because that's a long way. Instead, see where alpha is D? Just hit that and it'll scroll down to the D's. And I'm going to turn, again, my diagnostics on. Okay? So if you got the 84, you can just go into the mode. If you don't have the 84, you have to go through the catalog. Okay, so now I'm going to rapid fire. I'm going to put a line, a quadratic, parabola, and a cubic on there. Stat, calculate, a line. I'm going to put mine in Y1. Look at the R. It's always R squared. Don't worry about R. A 96% fit for the line. Go look at the graph. That wasn't bad, right? I mean, imagine you're going to go get that, your fancy clothes, 96% fit. That's pretty good. Okay. So I'm also going to stat, calculate. I'm going to go find a quadratic. I'm going to put that in Y2. Look at how well that fits. 97.6%. Not a lot better, but maybe that sleeve that just kind of rode up onto your hand is now back that ½ inch. Just right. But that one part of the collar is like still right up there in the back of your neck. And then I go stat calculate a cubic. Oh yeah, for the storage, if you don't remember how that works. Okay. Alpha trace brings up shortcut menus on the 84s. If you don't have that, then you go through the old school menu. You go variables, the y's, the function. In this case, I wanted Y3. Look at the correlation coefficient on this one. 1, meaning 100%. Meaning this is the model that made these points. It is perfect. Now look at the graphs. The line was pretty close. If you thread the middle, that quadratic was pretty good, but that cubic is dead on. Okay. We didn't have to do all three models. The n+1 point principle tells me. It says, I've got 4 points. What's a polynomial function that passes through the 4 points? A cubic. Okay? That cubic. X cubed minus x squared plus 2x minus 3. What was it? Minus x squared plus 2x minus 3? Yep. Okay? That is the cubic that makes these points. Perfectly. So, go find me a polynomial of some kind that fits these points perfectly.
So if there's 4 points, it should be a cubic?
It should be, yes. That's the n+1 point principle. There is a proof for it. I know you don't want to see it. So I'll just say, do you believe in magic?
No. What's your dream magic? I can actually. Yeah, cards.
These are all magic cards. We got a big donation. Kyle something.
Kyle? What up, Kyle?
Yeah, there's a guy that moved to the area a while back. Nice guy. Had a bunch of just bulk cards. Most of them are worth like 5 cents. But we can make decks out of them. We can give them out to kids. We can get kids playing the game for free. So it's pretty nice.
Oh, 1.3 E.
I want you to think back to the first time that we did linear regression in here, and y'all crapped your huggies. Because, calculator! This is so difficult.
I don't know. All I know is I did mine first. I don't know how. The thing turns. I don't know. Whatever the coefficient turns off once you equate clear the memory, doesn't it?
Yes, it does. Every time you reset your calculator, okay, stat edit thing, -2, 0, 2, 3, 1, 5, 9, 36. If I type my stuff in, I see 4 points. 4 points means cubic's going to fit it perfectly. Stat calculate, go make me a cubic. Store it. And then when I go to calculate, exactly as Callister just said, hey, where'd my coefficient go? Every time you reset your calculator, it defaults to not having the correlation coefficient on there. Okay. How do I write this? Because some of you are kind of struggling with it. Okay, first up, 1.6s. How about 5/3? 1 2/3 is 5/3.
Okay, sorry. I got it now. Sorry. We're good.
Okay. What does that mean when I say E -12? Times 10 to the -12th. What does it mean to do 10 to the -12th? Move the decimal. So that's saying 1 point, I can't even see that. 1.2 times 10, 3. 1.3 times 10 to the -12th means I'm going to move that decimal to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. And what do I do with the intervening spaces? Zeros. This is round off error from the calculation. It's 0. The coefficient of x squared is 0.
So it's just not there.
And then 4 2/3 is 14 minus, can't go mixing colors here, minus 14/3 x plus 5. Okay?
Wait, where did you get the 14/3?
4 2/3.
Oh, I see now. The C.
Okay? But do y'all see the A, B, C, and D at the top? Okay? So if you recognize a rational number, hey, this goes all the way back to the beginning of the year. Do you remember what a rational number is?
Oh,
Can be written as a fraction. If I see decimal stuff, how do I know it can be written as a fraction?
it's a decimal.
Not every decimal can be written as a fraction.
No, you're right.
Only if it's terminating. If I see a terminating decimal, If that says 1.125, done. What place value does that go out to? Thousands, right? Tenths, hundredths, thousandths. So that's 1 plus 125 thousandths. Reduce it down, 1 and 1/8. This is 9/8. Okay? Or if I see a repeating decimal, you take the repeating part. It was a 6 repeating, correct? So however many digits are repeating, put it over that many digits of 9. Y'all didn't know that? Like middle school? Point. All right, y'all got a calculator. Go back to the main screen. Point 1.81818181818181818. Spam it as many times as you can, and then hit math. Change it to a fraction. Nope.
It's 211.
You take the repeating part and put it over that many digits of 9, then reduce it. Okay? So, if you ever recognize a decimal in the regression algorithm like this, and you know that this is a certain fraction, write it that way. All right. So, can you all do the thing? We seem pretty good about it. So, that's just the mechanics of it. Can you do the thing on the calculator? Now we have to start answering questions with it. It's not like our probability statistics unit, which I don't know if we're going to get to. Y'all are actually doing pretty good. Normally, I leave wiggle time. On our normal schedule of events, you're actually 3 days ahead. But we need to put in rationals with your group. This is the first year that we're putting rationals in to Algebra 2. Was that Big Bird with flippers? Okay. I hope he's doing okay. I heard he's been having a rough time. Yeah. Been having some events at school. How do you say milk?
Like some people say milk. I want some.
It's milk, not malk.
Some people say milk.
You from Boston?
Yeah. Yes.
Or are you from Wisconsin? Okay. So, one, before we get started on this, I have to apologize for the examples that they use. I don't know why they use these examples. We're just going to run with them and make fun of them. We have milk production of Wisconsin. Milk. How much milk does Wisconsin make?
A lot.
Okay. Chart shows how much milk Wisconsin dairy farms produced in these years. Okay, listen to the directions. What linear model best fits the data? So, they specifically asked for a linear model. So I'm going to make a linear model.
I did not start a movie. My back hurts.
Really, I thought it was the lack of attention you received at home. So, I'm going to turn this into a table. Plug in my data. But before I go plugging in my data, we've run into this before, I probably don't want to put in 1955. What should I do? Years since, meh, but you have to define what that is. So we got to come to a consensus so we all get the same thing here. Since 50? Okay. So if you ever do that, write it. Okay. So if you do that, make sure that you actually write it. Then I'll come back here. Okay, I just did a bunch of stuff to my calculator. You know that you can get rid of stuff without resetting the whole thing. You go second plus. Before muscle memory takes over, look at your other options. I can clear my lists. I can just clear out list 1 and list 2. So option 4, clear my lists out. Now when I stat edit, it's still there. But because I've cleared the lists, but I left the stat plot on, that's one less thing I have to go do now. Because it will automatically plot whatever I'm about to write. So I'm going to say 5. What? Oh. 55. Oh no, I accidentally typed my stuff in the wrong list. That's okay. I'm just going to come over here and write the other ones. 16.5, 22.4, 22.9. Oops, I typed my stuff in bass-ackwards lists. So, when I go to make my linear model, stat, calculate, linear regression, what can I do to make it flip back to XY? Change your list. Second, list 2, second, list 1. I still want to store it. Okay. It might happen fast. I want you to watch what it says right here. Oh, it was in the middle. If you're on an old TI-83, what you'll do is it'll say lin reg. It defaults to list 1, list 2. So if you want to change that, you write list 2, comma, list 1, comma, y1, like this. You say, how am I going to English that? How am I going to put in commas? Do you see the comma button?
No. Oh, I do see the comma button.
Okay. So the 84's got that cute little pop-up menu. If you have to do it on 83, you just type it like that. I now have data. I got a linear model. Y is 0.128 x plus 16.76. I could turn those into fractions, but since they're terminating decimals, I'm okay leaving it. Also, my problem started with decimals, so I'm okay putting decimals on there. What's up, bud?
Why does it say r squared and r?
Take college stats and we'll tell you all about it. Effectively, it's the difference between variance and standard deviation. And variance is just used to find standard deviation. So don't worry about it. Just look at r squared. Okay? So, cool, I got a model. Use a model to estimate milk production in 2000. I want you to look at your data. Is 2000 inside my data or outside my data?
It's inside.
Okay, do you remember what that's called?
Inside the data.
Interpolation. What's something outside my data?
Yeah, like that. Linear, bro. It's a linear
Okay.
question, right?
Okay, you're fighting with your calculator. He's staring lovingly at the back row. Like, what's going on here?
Oh, you suck. You sus.
Okay.
I'm good. You missed it, bro. I haven't. I just saw it at the bottom.
The number of times in high school I got caught and I was like, nah, just looking at that behind you.
Concerts are okay.
Okay. Since I've got this, where's the easy place to figure it out? Where's the easy place to figure out in 2000 I made this much milk? Okay. Second, table settings. Over to ask. And I'm going to say, what? 50? So, at that point, I would still use a line because we learned in geometry that is an axiom. One of our postulates of geometry is 2 points defines a line. So, so I got that. Use a linear model if I want to say 1995. Well, just going to come back here and do the same thing. I'm going to say 45, right? Now, if I turn my diagnostics back on, and I calculate my linear regression again, I just want to see what that correlation coefficient was. Okay. It's not a good fit. This is, I'm trying to cram into the only suit that I own 2.5 years after child number 2 and all of the stress eating. That ain't happening. That's like Chris Farley, fat man in a little coat. Okay. Like, I will rip the back of the jacket. 80% fit. Zoom to your stats and look at what happened to the line compared to the points. Zoom to the stats doesn't work if you don't put your stat plot on. Zoom to my stats. There we go. That's better.
Whoa. Actually, just like the line.
What?
That's what I have. The zero. What a heck? What's this?
Did you enter the years on it? There's a long list.
Right. Remember I put mine in the wrong spots?
Oh, you brownie boy. He figured out before we get
A little bit better?
Alistair said it.
Okay. It is the line of best fit, but it doesn't fit very well. Okay. Because, flip it over to the next part, the graph shows the quadratic model for it. Because if I had 3 points, there should have been a quadratic that fit it perfectly. So, our linear model, whatever we just said, what was it again? Like 0.128?
0.128x plus 16.
You know what, let me make sure I get my 0.128x plus 16 what?
0.76.
And my correlation coefficient was about 80.8%, I think.
Yeah. Let me get it up.
Okay, if I do that same thing and I say stat, calculate, let's make a quadratic model instead. List 2, list 1, because mine are backwards. I'm going to store mine in y2. Look at my correlation coefficient, 1. So there is a quadratic that meets this data because there's 3 points. 100% fit. It's perfect. It is negative 0.00432 x squared plus 0.3872 x plus 14.672. Why am I writing all these extra decimals? In this case, because they were terminating decimals, I'm just going to write the whole thing. Yes, ma'am.
So when there's 3 points, we do a quadratic. 4 points, we do a cubic.
Yes. N plus 1 point principle. Okay. But on that last problem, they specifically told us to make a linear model. Okay. They're telling us that to lead us to what this lesson's all about. You know how to press the buttons. But take a look at the line versus the quadratic. The line has about an 80% fit. The quadratic, 100% fit. That's, dude, just go get a new suit. Just, you ate yourself to a new wardrobe. Go get a new suit. Okay? That fits perfectly. So now I have that model. I have y equals this, and it was 100%. It was perfect. Given that both models are, decent fits, which one is more likely to represent the milk over time? That's what today is about. Right now, look at my window. What year does this go out to? The year 60? 2010, right? We said X is year since 1950. So let's go out to, what, most of y'all 16? 16, 2021. So, oh, gross. Y'all were like born in 2005? Okay. Don't hurt me like that. You ain't getting air knuckles for telling me I'm old. So let's go out to, you know what? How about we just go another 10 years? When the likelihood is a good chunk of you are weaning that first kid off of breast milk and formula to regular milk. So now you need to pay attention to the price of milk. Oh yeah, it's coming down the pipeline. Please don't reproduce. So let's go another 10 years past right now. 2031. What do I put in? 81. Right? Okay, let's go from 0 up to, the line kept going up. I don't know, I'm just going to go like 50. The linear model, the quadratic model.
Because it doesn't have any more points to keep going.
So what's going to happen? They said over time. What happens when I go out 100 years? What happens when I go to the year 2050? What happens when I keep going out? What happens, y'all about 16, let's say in another 50 years from now? We're looking at retirement age, when you are actually going to complain about things like milk. Okay? It costs $32 for a gallon. Why should I be doing this, right? So let's go out further. Another 50 years from now, 2071 is what? 121 years out? I'll just go 125. Okay, so now Tell me again, what was X in this problem?
Years since 1950.
Okay. What was Y?
Price of production in billions of pounds.
Billions of pounds of milk in Wisconsin. I want you all to hit trace. Look at what it's tracing right now. Look at the top of the screen. If I arrow down, now it's tracing the line. Let's go out to the year 2070. 120. The line says, we still making milk. The quadratic that fit my model perfectly now says that not only is Wisconsin no longer producing milk, they are actively rolling around the country killing cows so there's less milk. It doesn't make sense. It does not make sense. Okay? That's what I want you to get out of this right now. We need to start writing some notes to it. Okay? Wisconsin's killing cows. No. That too. When you're assessing a model for which one is more reasonable, if I am interpolating, I'm looking inside my data set. If I'm looking inside my, right? If I look inside my data set, then I'm going to choose whoever has the best fit. So if I was choosing something between, what was it, 1955 and 2005? If I was choosing something in that data range, then I would pick the quadratic because it had a better fit. But if I ever extrapolate, which is outside my data, see, inside my data, extra, outside my data, then I'm going to choose whichever is the most reasonable. In which case, we now have to start asking the questions, even if I math right, am I allowed to use the one that's a worse fit? In this case, it doesn't make sense that over time, Wisconsin starts mass murdering cows. It doesn't make sense. So I would choose, over time, I would choose the line. Even though it's a worse fit, it makes more sense. More cow. Bell. More cowbell. Y'all never seen the old Saturday Night Live skits with Christopher Walken, have you?
Yeah.
More cowbell? No?
You should play it. I've seen it at a restaurant.
All right. So, next up, it says, if 4 data points were given, would a cubic function model the data better? So let's say, I'm just going to make something up. If I go stat, edit, let's say I added in another thing. What if I said, right now, this year, 2021, so what's that, 71 years after? What if I said Wisconsin this year is making 24.3 whatever something billion pounds of milk? Okay. So now I stat calculate linear 1 stat calculate quadratic stat calculate cubic. Okay. Now take a look at it.
Whoa.
I added another point. I just made up a number. I had 4 points. There is a cubic that fits it perfectly. I go back to my graph, and I see my line. I see my quadratic. What the? And I see my cubic.
It's a brownie point. Come on now. It's distracting me. I was excited about the graph. Just give him one.
Yeah, I'm kind of headed there. So if I did that out again, what was it? 175 years or whatever. To 40. Okay, if I just make my window big enough to see the whole thing, now I see my line, I see my quadratic, and I see my cubic. Now I have to ask that question again. If I trace and I say in the year 2021, so 71 years, oh wait, why did it do that? Because I didn't pick one of the graphs. Remember, if I trace, look at what it's trying to trace right now. It's trying to trace my list of numbers. I need to be on one of my graphs and then say, this year. Well, all 3 of them are fairly close to each other. If I go out another, I don't know, 20 years from now, so 2031, well, they're still all about the same. Keep going out. Go out 100 friggin' years. Go out to 2050. Reasonable. Still reasonable, but getting worse. Starting to take off like crazy. Now we're like making genetically modified mutant cows that got 38 udders. Okay? Where it's more like you raise the cow and you just throw it in a machine and it's a husk and now I have milk. Okay? Like you So maybe the cubic also doesn't make sense. Because yeah, it is increasing. It will go positive. It'll never go negative. It doesn't make sense if it's negative, but it also doesn't make sense if I keep going out and I trace to I don't know, 160 years out. Look at the line. Look at the quadratic. Look at the cubic.
Holy schmackerolies.
Okay, it doesn't make sense in the context of the problem. So that's the heart of what today is about. If 4 data points were there, would a cubic fit it better? Yeah. Would it be more reasonable than the quadratic? Yeah. Might it still not be as good as the line over time? Yeah. So you have to be able to make that judgment call. All right, that's all just regular data table set. Okay, there we go. So we're going to set up with a new table and answer those same questions. Average consumption of cheese per person. How much cheese do you eat? Lies.
Okay. Like,
I want you to think about the cheese on a burger. I want you to think about the cheese melted into your homemade macaroni and cheese. I want you to think about the cheese on your pizza. I want you to think about the random string cheese stick that you grab as a snack. I want you to think about deep fried cheese curds. Okay. Or, if you're like in my household, we literally just buy a pound block of cheese, cut it into a bunch of slices and just have it sitting in the fridge in a container so you can go grab a chunk of sausage and a chunk of cheese and that's your snack. Okay? I want you to think about over time why that number is going up. Think about our production capacity. Think about our processed food. Think about us throwing cheese on everything. Okay? So, it specifically tells us to go find a cubic model. Go find a cubic model. Hey, what should we be doing for our time? Harrison. Getting awkward, right? What should we be doing for our time on this problem? How's that working out for you?
I haven't started it, so I haven't.
If I have a table with time, particularly years in it, define your starting point. Starting from 1900 would probably be the best, right? So state that. Say X is years since 1900. When you do that, you get to just
10, 40, 70, 75,
turn that into all that junk, and then I'll call this 101. Okay, so get that in your calculatron. Set, edit. Data in your table. How do I get my cubic model and store it? Stat. Calculate.
Down to 6.
Make sure your lists are right. Oh no, I'm not on TI-84 because I don't have one personally. I have to use my TI-83 emulator on my laptop to do my homework.
That does not matter.
Variables. The y's, the function, y1. How do I write that? If I have 9.242e negative 5. Okay. I see, come here. Y is 0.1234 zeros and then that stuff. X to the third. Minus 0.00958, also call it 96x squared, plus 0.311x plus 1.802 with an R coefficient of 99.76%. So it's a very good fit. Graph the function with a scatter plot of the data. I'm going to tell you right now, you don't have to go actually graphing it on your paper. I'm fine with you just doing it all on the calculator screen anyway. Okay? Use cubic regression. Check. Get a scatter plot on your screen. Stat plot on. Zoom to my stats. There you go. We got a cubic. Okay. Use a model to estimate cheese consumption for 1980, 2000, and 2012. So I will second table settings, switch that over to ask. Go to my table, and I will type in what, and what. 80.
80 and
100. And 2012.
112.
Okay. Now it asks, in which estimate do you have the most and the least confidence? Okay, if I change my window to go out to at least the year 2012, so I'll say out 150 years. Okay. It asks us to find this trace at 1980. How confident do you feel about that result?
Pretty confident.
The year 2000. That's almost on top of one of my data points. I feel real good about that. But then I moved to 2012.
Not so confident.
This thing shoots off into the wild blue yonder. What if I kept going further and further and further, and now I said, Rutrow, it's your retirement age. I go 50 years from now, 166.
Not so confident. That's a big jump.
Are we really saying that each person is going to be consuming 212 pounds of cheese every year?
Yes. No. That's cap. It's cap.
It's just cheese.
No, that's straight cap.
You're just going to sit down with a knife and a spork,
Every meal.
just have slices of cheese.
That's cap.
Okay? So, when they say which ones do you have the most confidence in?
That's cap.
The first two, because they are interpolation.
Reddish.
The other one, though, now we're talking about extrapolation. My model fits perfectly with interpolation. But as soon as I go past my data, it's getting kind of wild. Okay? If I switch over to a linear model instead, make a linear model, go with it, put it into Y2. Stat, calculate, linear model. Okay? Look at your R coefficient, though. That is not a good fit. You go look at your graph, that cubic fits perfectly. My line does not. But when I go to my table, now it auto-populates Y2 because I already asked the questions. Does that start to look more reasonable over time? When we already have data from 2001 that says 30 pounds of cheese. So sometimes you have to choose the one that's a lesser fit because it makes more sense. Okay? So in that case, estimate for all three. We already got them right there. In which of these estimates do you have the most confidence and the least confidence? So which one makes the most sense now for the line? These are the results for 1980, 2000, 2012 for the line. Which ones do you have the most and least confidence in? That's not even an answer. Okay. Yeah.
Yes.
I mean, that was exactly why we put you on the board, when you just answer random crap. So.
He's catching up.
Okay. What I get out of this is I want to use my cubic when it's interpolation. I feel good about that. But as soon as I hit extrapolation, I'm going to switch over to the one that makes more sense. Now, in this case, that's actually not too far off, right? But when I start getting that far out, now I'll have more confidence in the line. It all depends on which one's more reasonable. But things can increase or decrease exponentially, as we have witnessed firsthand in the last year and a half. So, can you answer this question start to finish on your own? One thing that wasn't in here, they don't do this in the Algebra 2 textbooks, and I don't like it. Let's go back to this one and say, what if I asked you part C? When will average cheese consumption be 35 pounds per person per year? Okay. See, everything that they were asking you so far is input year. What is year in terms of the equation? X. How do I put in Y? Gets tough, right? I don't know that that's explicitly in your book, so I want you to hear this part. If they ever ask you the Y part of it, I have to go to Y, and I have to plug in 35. How's that going to help me? What can I do now? The intersection. I didn't see anything happen. Oh, check out your window. Y's go from that to 34. That's fine.
36.
That's why I didn't show nothing. So there's my cubic, my line, and there's 35. If they ever ask you a Y value, go put it in a different Y portion of your graph. And now that it's on my graph, I calculate on my graph the intersection. And I say my cubic model with my line meet at in 2004 versus intersection of my line with my green, there we go, with my 35 says in the year 2044. Okay. I don't know that that's actually in the book, but I think they might ask it in the homework and just kind of expect that you can figure that out. Wow. I want to show you stuff instead of just, hey, figure it out. Okay? So if they ask you an X, you plug in X. We've been doing that all year. If they ask you Y, you have to put it in a separate Y and find the intersection. Okay? Show me some thumbs. How we feeling about this calculator stuff? Okay. What is your correlation coefficient to your understanding? Okay, 0.80. We've got more than enough time. Let's try one more time then. Okay. So let's do this stuff. I'm going to add in there number was there. So I'm asking you an X and a Y at the end of it. Both estimate the silver production for 2000 and estimate the year in which we hit 12,000 metric tons. Okay? Yes. Yo. You killed your calculator? Do you have the white circle of death? Second. Off. And on again, just like customer service tells us to. Okay. But all of your stuff is still there. So you just try again. Now we're starting to get to that stage in this class. I just got done chewing pre-calc out about that. If you see the little yellow circle up in the top right corner, it's thinking. Leave it alone. For example, I don't know how well Rylan would do on his next test if in the middle of his problem I was like, do faster, faster. Why aren't you doing it? Rylan, why aren't you doing it? Why aren't you doing it? He's eventually going to break down and not be able to think anymore. Okay? And you get that Mortal Kombat toasty, right? Okay? So if you got the yellow circle, stop pressing buttons. It's thinking. Okay? If you see the white circle of death, you do not need to reset your calculator. You literally do what customer service tells you to. Second, off, and then turn it back on again. Now this is emulator, so it's not going to turn off. But, okay. Yeah, if I ever get the white circle of death up there, I just hosed. I have to reset. But if you literally just turn it off and on again, it'll be fine. Okay. What is this?
So, what is that? What is it? Grape?
Oh, that's a chocolate covered blueberry.
Chocolate covered blueberry.
I was going to say, y'all are teenagers. You'll eat anything.
all day. I don't know. Why is our thing just keep being sushi fat?
It's a 3,000-second rule. Just go for it.
Okay, I have to find like the y for like on this calculator. I don't know how to do that. Like to find like I don't know why.
I think you can just go to a different graph. Can you put them on the same graph?
What do I do?
I have no idea. Okay. Sketch. Second sketch. Close. Exit. Graph 1. Graph 2. Okay. Set. Okay, settings for each graph. There's got. I know you have to be able to put them all on the same one.
Like you can put like all the lines, but not for like you can do it for like linear and quadratic and like cubic. You can put that on the same graph. But I don't know how to put like where I can time
Test. Well, there you go. That's how you put all three graphs on the same one. Graph. Okay, so that'll. Oh, okay. Exit. You. How did you do your calculation again on these? Like to actually get the model?
to get the there's like the
Okay. So, say you're getting your cubic. Draw. All
and then
right.
like to get the other one to get like just a line, you just click X again and it does a line for the same.
Okay. And then, oh, I know it shows up as just intersect. Okay, so that was in graph 1. They're all saying the same thing. Okay. All three of your graphs are saying the same thing. I know you get one, you get the other, you set it to draw both graphs at the same time, and then I think you just, once you get both of them on the same screen, I remember seeing a kid do this in pre-calc, you just literally move the cursor around and it will highlight the intersections.
Well, like okay, so you can do
So,
that. Here,
so get your cubic and your y equals 12,000 on the same
I
screen.
don't know how to get the y equals 12,000 because like you can do here's a line and then I don't know if you need the line or not, and you just go back and then like cubic and you can put them on the same one, and then if you do shift trace or no,
Yeah.
I don't know.
So we can't get the 12,000 on here.
Yeah, I just don't know how to do that.
Okay. It does say estimate. If you want to just trace it until you see the y is close to 12,000, call it good. You can also take whatever your model is, subtract 12,000, go find the zeros. Because that'll solve it for 12,000. So, all right, back up. It happens. So, start to finish. Second plus 7, enter 2. All the way back to the beginning, mode. Stat, edit, 0, 5, 10, 15. You completely missed 0. There you go. You
Why is it not like
because Frank has delays.
oh, it like combined those?
Yeah. Okay. I've got stuff. What's going to be the best model for it? And how do I know? Cubic, because 4 points. If I've got 4 points, I will. Now I'm going to find them all. I'm going to stat, calculate, linear regression in one. That is horrible. 5% fit.
Is
That's me like one of the ladies of Sturgis with just a spaghetti strap and pasties. Okay? Like 5%. That is terrible. Okay? So stat, calculate. We probably don't want that one. That one's really bad. Quadratic regression. 40%. Still not very good. Stat, calculate, cubic. 100%. Okay. I'm going to turn my stat plot on. I'm going to make it a different color just because I can. Then I will zoom to my stats. Okay. You see where the line and the quadratic are absolutely terrible. Okay. Absolutely terrible. So I'm definitely going with the cubic. Estimate your silver production in 2000. I can go to my window and change that out. What was this again? Years since 1950?
yes.
Okay, so we need to go way further than that. Let's go like 100 years out. I'm going to say between 0 and 30,000. I really want to extrapolate. This is going out to the year 2050. Do you see where, as I extrapolate, the line might actually be the better bet? So they said, estimate the world's silver production for 2000. If I trace out 50 years on the line, does that number fit with what I saw in the table? Yeah. The quadratic. We have destroyed all silver on the planet, and we are actively searching the universe for more to destroy. Okay? Versus the cubic, even though the cubic fit it perfectly, in the year 2000, the cubic says you have enabled creator mode. And you're just like, silver, 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 everything silver. It doesn't work that way. So if I'm estimating in 2000, which model should I actually use? I should actually use the linear, even though it was absolute trash. Okay? The linear model was trash, but if I'm extrapolating out that far, it's the best fit. And then the year in which we hit 12,000, well, that depends which model you're using. Okay? So, the formula plug and chug stuff on the calculator. You should all have access to a calculator. It is on your laptop. Y'all remember where to find it. We've gone through it enough times. I can attach the old video for linear regression to remind if you want. It's literally like 6 years old or whatever. So I'm pretty sure I just did it on my phone, but you should be good to go.